So our first problem over here is as written on the screen. It is said that a uniform meter rule of mass 100 gram is balanced on a fulcrum at mark 40 centimeter by suspending an unknown mass m at 20 centimeter. So before going into the questions that has been put forward to us, we first have to see that what are the information that is given to us. So let us go one by one. Let us see what are the information that is given to us. First of all, it is said it is a uniform meter rule. It's a uniform meter rule. What does a meter rule mean? It means it's a 1 meter ruler. That means 100 centimeter ruler. So first I will draw a uniform meter rule. Say it's like that. Here it is 0 centimeter and here it is 100 centimeter. Second, what is given to me? It is having a mass of 100 gram. So this meter rule have a mass of 100 gram. So where does the mass of any body act upon to provide the gravitational force, or I will say where does the gravitational force acts on any body? So it is obviously at the center, that is at 50 centimeter mark for this scale or for this 100 centimeter ruler. So what is the force or the gravitational force acting over here that will act downwards? So mass is given as 100 gram. So 100, I can write 100 gram force that is acting downwards. Now it is balanced on a fulcrum at mark 40 centimeters. So 40 centimeter will approximately be this one. So here is my fulcrum. Now after that what is said? So this I have already got three information. Number one is it is a uniform meter rule. Number two, there is a mass of 100 gram which I have written over here, which is creating the gravitational force. And number three, it is balanced on a fulcrum at 40 centimeter. So that also I have shown in my diagram. Now after that what is said? It is said by suspending an unknown mass m at mark 20 centimeter. So I first plot what is 20 centimeter. So here there is one mass suspended. Say it's like this. Now at this condition they are saying that this rule is balanced. Look at this word. This rule is balanced. So this is in equilibrium condition. Now what is my first question that has been given? Find the mass m. So for finding any question which is involving any meter rule and this kind of fulcrum and balance situation, our first target is to find out anticlockwise moment and clockwise moment. So what is the anticlockwise moment on the left side of the fulcrum? Let us see. I'll write ACM. So what is the anticlockwise moment? Here it is acting, only one moment will be formed due to this mass m, that is m into distance from the fulcrum, that we already know from our theory classes. So what is the distance from the fulcrum? 20 centimeter. So I write m into 20 centimeter. So this is my anticlockwise moment. Okay. So m gram into 20 centimeter. Now I'll find out what is my, after that, clockwise moment, cm. Now let us see what is in the right hand side of the fulcrum. This will form the clockwise moment. If you see, this is having this kind of direction, this is clockwise, and this one was having this kind of direction, that is anti-clockwise. So what is the force that is acting over here? 100 gram force is there. Here it was m gram force into what is the distance? Here the distance is 10 centimeter. So what is the clockwise moment? The force that is acting, that is 100 gram force, into what is the distance from the fulcrum? We have already calculated 10 centimeter. So now I have got clockwise moment and I have also got anti-clockwise moment. So as per principle of moments, I will write in short form. Anti-clockwise moment is equal to clockwise moment. Here in examinations you have to write the full form of all these things. Please do not write the short forms. So what is my anti-clockwise moment? M into 20. I am not writing any unit over here. Then into 100 into 10. So from here I can easily calculate what is the M. It will be 50 gram force. So my first question what was given to me was that find the mass M. So this 50 gram created a gram force of or force of 50 gram force. So mass suspended is equal to 50 gram. So my first problem is solved. What is my next question that has been asked? To which side the rule will tilt if the mass M is moved to mark 10 centimeter? So this mass M is moved to mark 10 centimeter. Okay. Now beforehand it was at 20 centimeter mark. Now it is at 10 centimeter mark. So let us first rub all this thing. This thing we have already completed. So we'll go up to the new one now. New problem what has been given to us. So now my mass is at 10 centimeters. So this thing is not there. So the mass has come at 10 centimeters. So this one is not required. This 20 centimeter mark has no importance at this moment. While I am doing this problem, please do the problem yourself also. Don't just see it, because it will create more understanding when you do it yourself. Okay, now let us see. It is at 10 centimeters. So what is the distance now? Distance is 30 centimeters. And what is the mass? Mass is 50 gram. So it will create a force of 50 gram force. So let us see what is the anti-clockwise moment. 50 gram force into 30 centimeter. And what is the clockwise moment? 100 gram force into 10 centimeter. So which moment is more? That we have to calculate. Here it is 1500 gram force centimeter. Here it is 1000 gram force centimeter. So this is more than this. So which is more? Anti-clockwise moment is more. So from here I can directly say, so there will be a net moment on anti-clockwise side. So to which side the rule will tilt? The rule will tilt on side of mass M. Hello. So now we know that the rule will tilt on the side of the mass M, that is on the left hand side, and the net moment will be anti-clockwise moment. This will be the net moment. Now we go and find out what is the third question that has been given. What is the resultant moment now? Now, what is ACM? Anti-clockwise moment is 1500 GF centimeter, and clockwise moment it is 1000 GF centimeter. So, what is the difference between them two? Remember, when you have to find the resultant, you just have to find what is the difference. That's it, nothing else. So here we can see there is an anti-clockwise moment which is 1500, and there is a clockwise moment which is 1000. So if I have to find the resultant moment, it becomes 1500, because for ACM or for anti-clockwise moment we consider it positive, and for clockwise moment we consider it negative. So 1500 minus 1000, it becomes 500 gram force. So the resultant moment that we have got is positive. So it is anti-clockwise. Try to observe this, how I have done it. I have calculated the anti-clockwise moment 1500 gram force centimeter, and I have calculated the clockwise moment which is 1000 gram force centimeter. Now I have calculated the resultant moment. How do I calculate it? First I considered anti-clockwise moment as positive and clockwise moment as negative. This is a sign convention that is used. This you must be clear with in your theory classes. So 1500 minus 1000, it becomes 500. So 500 gram force centimeter is the net resultant force, resultant moment, which comes to be anti-clockwise because it is positive. So it is anti-clockwise, ACM. So net moment is anti-clockwise moment. So now there is a net force or a net moment that is acting upon this mirror rule on this side, on the left side. Now what is our fourth question? Fourth question is said, how can it be balanced now by another mass of 50 gram? Obviously now we are having one anti-clockwise moment on the left side. So to balance it, obviously I have to put the new weight on this side, 50 gram, to create some clockwise moment. So I have to, as my anti-clockwise moment is 1500 and my clockwise moment was 1000, so that is, there was a net difference of 500 gram force. So I have to now put this 50 gram on this side. The question is, how do I balance it? It's not much difficulty. Again I calculate the ACM and the CM. So in case of calculation of ACM, my mass is same, 50 gram force into 30 centimeter. That will be my anti-clockwise moment. So I'll write 50 into 30, that will come around 1500 gram for centimeter. And now the clockwise movement. Let us see. So who will be contributing the clockwise movement now? One is the weight of the meter rule itself, 100 gram force into 10 centimeter, that is the distance from fulcrum. And there is another 50 grams that has been added. Now I do not know where it has been added, so I can put this as x. Okay. So what is my clockwise movement? I'll do it over here for simplicity so that I can see the diagram, basically nothing else. So clockwise movement will be 100 gram force, means this one, into this 10 centimeter into 10 plus the new weight that I put over here, say 50 gram force that is given, into, I do not know what is the distance from the fulcrum, that is the unknown part. So I keep it 50 into x. So this is my clockwise movement. So it becomes 1000 plus 50x. Now I can use it. So it becomes basically clockwise moment is 1000 plus 50x. So as per POM, what is POM? POM is principle of movements. Do not write this short forms as I am doing over here in your examination. So 1500 is equal to 50x plus 1000, that is anti-clockwise movement will be equal to clockwise movement. So what will be the x? If I calculate from this, my x will come to 10 centimeter. So where is this 10 centimeter mark? So it shall be 10 centimeter for the fulcrum. That means this x should be 10 centimeter from the fulcrum. So where the fulcrum is located? 40 centimeter. So 10 centimeter from 40 centimeter means it should be at 40 plus 10, 50 centimeter mark. So by putting a mass of 50 gram at this position, exactly at this position, another 50 gram if I put it not at this position. This we have shown just to assume that it is somewhere in this side, but after calculation we have seen that it will be at the 50 centimeter mark along with the weight it is acting on. So at this point if I put this 50 gram, my meter will be balanced again. I hope this problem is clear to you guys, and this kind of problems come in examination, you can now easily solve them. Now let us go to the second problem. It is said a physical balance has its arm's length of 60 centimeter, and say the physical balance is like this. One arm is 60 centimeter and one arm is, another arm is 40 centimeter. Now next point what is given is what weight kept on pen on the longer arm. So there is a pen over here, there is some weight W shall balance an object kept on this arm. Another weight is there, say W2, which is given as 100 gram force. So basically for the physical balance, this is your fulcrum position. So here is there is a weight which is at 60 centimeter from fulcrum, and here there is a weight which is at 40 centimeter from fulcrum. So this will act on the anti-clockwise direction AC, and this will act on the clockwise direction. So first we calculate the ACM W into 60. This is my anti-clockwise movement, and then we calculate the clockwise movement. 100 into 40. Now as per POM, ACM is equal to CM, that is anti-clockwise movement is equal to clockwise movement. Please do not write the short forms in exams. I am writing it for the sake of time, and I am a lazy person, that's why. Just like you guys are also lazy and I am also lazy. So here W is equal to 400 by 6. So it will come about 66.67 gram force. So if you put this weight on this side, 66.67 gram force, then it balances the physical balance. It was pretty easy after doing that problem. It was very easy. There is a problem on steering wheels. So if there is a steering wheel in your car which is having a diameter of 0.5 meter, and there are two equal and opposite forces of 2.5 Newton acting on it, 5 Newton acting on it. I'm very sorry about this. Acting on it. So here we have to calculate the resultant moment. So if I see this one, this force of 5 Newton is acting in anti-clockwise direction, and this force of 5 Newton is also acting in anti-clockwise direction. And here the center is my fulcrum. So what is the distance over here? This is 0.25 meter, and this is the radius, basically 0.25 meter. So for this one, the moment is 5 into 0.25 Newton meter, and for this one the moment is 5 into 0.25 Newton meter. So as both are anti-clockwise, so this should be added to get the resultant. So both are positive, basically. Here is no negative. In the first problem there was one clockwise, that's why we have taken negative. Here there is no clockwise thing, so it is positive. So if you add these two, it will come to 2.5 Newton meter. This is one way of calculating it. You can also calculate moment, because as these are equal and opposite forces acting, so you can also calculate moment of couple. How it is calculated? Moment of couple, it is basically force, because as it is equal and opposite force, so any force you can take, force into the distance between them. So this one 0.5, so 5 into 0.5, that will also come to 2.5 Newton meter. So this is clear, very easy. This was a problem on couple. Rest of the problems we'll discuss again in our next video. So for today there will be these three problems which you digest, and after that we'll discuss in our next video there are another three selected problems on moments we'll discuss in our new video.